Local AI agent, from confusion to clarity. Architecture, model dependencies, DIY runtime, and vertical domain agents. July 2026. Table of Contents. Part 1, Architecture Demystified. Part 2, Model Dependency. Part 3, DIY Agent Runtime. Part 4, Vertical Domain Local Agents. Part 5, Open Source Learning Roadmap. Part 1, Architecture Demystified. Every AI agent has two independent layers. Agent Runtime, the execution framework, handles task decomposition, React loops, tool calling, file I/O, and memory management. Examples include OpenClaw, Codex, Claude Code, LangGraph, and Hermes. Its role gives the LLM hands and feet to operate the system. LLM Inference, the reasoning brain, handles thinking, planning, and generating tool call instructions. Cloud Brain, GPT-4, Claude, Gemini API data leaves your machine. Local Brain, Llama or VLLM running Qwen, Llama, DeepSeek locally. These two layers are completely independent and not bound to each other. OpenClaw and Codex, local hands, Cloud Brain. They are agent runtime tools. They determine who executes local operations, not whether the entire system is a local AI agent. OpenClaw, local resident execution gateway, defaults to Claude or GPT for reasoning. Only execution, file, and command operations remain local. All thinking goes to the cloud. Codex from OpenAI, terminal execution layer, cloud model drives, local sandbox executes. Core reasoning happens on the OpenAI cloud. Even if you download and install OpenClaw on your own machine, as long as it calls cloud APIs for thinking, it is not a local AI agent. Local AI agent, 3 mandatory requirements. Requirement 1, Local Inference Brain. LLM deployed entirely on local machine or private server. User text, files, task plans never leave local hardware, no third-party cloud API. Requirement 2, Local Agent Runtime. Task loops, memory using Chroma or Face Vector database, tool scheduling, all execute locally. Requirement 3, Local Environment Interaction. File I/O, shell commands, desktop control, databases, intranet services. Everything stays within the local machine or LAN, never leaves. One-liner, hands plus brain plus environment, all 3 locally closed loop. 3 architectures, clear comparison. Pure Cloud Agent, runtime in the cloud, LLM on provider servers, ChatGPT, WebClaw. Not a local AI agent, all data flows to external servers. Local execution plus cloud model, which is the OpenClaw default, runtime on your machine, brain calls third-party cloud API. Only a local execution agent, not a local AI agent. Pure local AI agent, runtime and LLM both on local machine or intranet. Standard local AI agent, local AGI, Llama plus LangGraph, self-hosted VLLM. The key distinction, where does the thinking happen? 3 common misconceptions. Misconception 1, software installed locally equals local AI agent. Wrong. OpenClaw, Codex, Claude Code all install locally, but their core reasoning relies on external cloud models. Sensitive data still leaks. Misconception 2, local AI agent means weak small models. Wrong. Local servers can run 70 billion or 405 billion parameter full models. Local only constrains data flow, not model size or task complexity. Misconception 3, OpenClaw cannot be a local AI agent. It can, but requires modification. Switch the model back into local Llama or VLLM, sever all cloud inference dependencies. Then it qualifies. Part 2, Model Dependency, the truth. Open-weight models, download once, run free. Open-weight models account for 99% of personal local AI agent usage. Qwen, DeepSeek, Llama, Mistral, many CPM weights publicly available. Distribution phase, one-time dependency, download weights from Hugging Face or ModelScope. The base model was trained by a vendor such as Alibaba, Meta, or DeepSeek. Runtime phase, zero dependency on the vendor, runs offline, no data sent back. Vendor servers down? API shut off? Network disconnected? Agent still runs. You can freely quantize, LoRa fine-tune, distill, zero vendor control. The rule, you only depend on the vendor at the moment of download. Closed source enterprise and the kitchen analogy. Closed source private deployments are enterprise only. Weights never fully delivered, encrypted images with authentication keys. Runtime requires periodic license checks and vendor push updates. No fine-tuning, disassembly, or redistribution allowed. This is true vendor lock-in, not relevant for individual developers. The kitchen analogy, cloud API, you go to the restaurant, pay per dish, chef sees your ingredients. OpenWeight, you buy the recipe once, cook at home forever, zero restaurant contact. Closed source enterprise restaurant gives you a locked robot chef with monthly fees. The core distinction, runtime data versus model origin. Local AI agent's definition does not care who trained the model. It only cares, does runtime require interaction with vendor servers? OpenClaw plus Cloud GPT API, not a local AI agent, thinking requires network, data flows to the vendor. Alima plus OpenClaw with backend switched to local Qwen, IS a local AI agent. Even though Qwen was trained by Alibaba, they see nothing at runtime. The extreme case, zero vendor dependency from training to runtime. Theoretically possible, build compute cluster, collect data, train from scratch. Practically, no individual developer has that level of compute or data. Part 3, DIY Agent Runtime, build your own. The 4 core components of any agent runtime. Number 1, message and context memory, short-term conversation window plus long-term local vector memory using Chroma or FAISS. Number 2, React main loop engine, user input goes to local LLM, parse tool call, execute, feedback, loop until done. Number 3, local tool sandbox, read and write files, execute terminal commands, read project code, access local services. Number 4, prompt formatting and output parser, split LLM output into answer text or tool call instruction. No industry standard mandates OpenClaw or Hermes. Build your own. 3 levels of DIY runtime complexity. Level 1, lightweight prototype, approximately 100 lines of Python. No LangChain, OpenClaw, or Hermes, pure standard library plus local LLM interface. Handwritten memory class, hand-rolled React loop, basic JSON parsing. Perfect for personal local use, fully autonomous naming and control. Level 2, engineering-grade runtime. Go, Python, or C# full implementation with custom message protocol. Custom skill plugin loader, sandbox permissions, daemon process, autostart. Examples, NanoAgentScope, Agency, OmniAgent, all from scratch. Level 3, native binary in C or Rust. Pure compiled language, few kilobyte binary, zero dependencies, fully offline. For servers, embedded devices, and industrial local AI scenarios. The 100-line blueprint, self-local agent runtime. Tool layer, self-defined local operations, read_file, write_file, run_shell, and calc registered in a tool map dictionary. Runtime manages its own tool registry, no third-party specification. React Engine Core, system prompt with embedded tool descriptions. The loop, call local LLM, parse tool JSON, execute tool, feed observation back. Step limit prevents infinite loops, max loop equals 6 by default. Key principle, the only dependency is the Alima library, zero agent framework imports. Self-local agent runtime is your invention, same conceptual level as OpenClaw. Runtime and LLM are completely decoupled, swap models at any time. Self-built runtime versus off-the-shelf frameworks. Using OpenClaw or Hermes, bound to third-party framework logic, plugin specifications, and permission model. Tool execution and context handling limited by framework rules. Potential telemetry and log upload must verify and disable manually. Fully self-built runtime, zero-agent framework dependency only depends on local LLM inference. Complete control, custom sandbox, permissions, task flows. Your own project name, protocol, and interaction specification. No external reporting code, fully self-audited, 100% local data. The judgment criterion is inference, scheduling, and tool execution all local? Part 4 for vertical domain local agents. Why these 4 domains need local AI agents? Core commonalities that demand local closed-loop operation. Number 1, highly sensitive data. IC-RTL and SPICE netlists, robot motion parameters, 3D printer STL and slicing parameters. These are core enterprise assets, cloud upload risks, intellectual property leaks. Number 2, strong local hardware binding. Local EDA tools, robot serial and ROS, 3D printer USB and LAN cloud cannot reach these. Number 3, massive local file I/O. Engineering files, simulation logs, layouts, robot datasets, material libraries. Number 4, low latency requirement. Real-time robot motion planning, instance simulation error repair. Cloud API network latency is completely unacceptable. Agent 1, Digital IC Design, RTL and Verilog. Local assets, .v and .sv RTL code, .sdc constraints, simulation test benches, waveform.vcd files. Local tools, Icarus Verilog, Verilator, Yosys, GTK Wave. Core local capabilities, batch parse RTL modules across project directories. Execute synthesis and simulation commands via local terminal. Autofix timing conflicts, syntax errors, module port mismatches. Local vector database for module reuse library and error case history. Why it must be local? RTL code is core chip IP, absolutely cannot upload to third-party cloud. Simulation commands only execute in local EDA environment. Agents 2 through 4, Analog IC, Humanoid Robot, and 3D Printer. Agent 2, Analog Circuit Design, SPICE. .sp netlists, device model libraries, simulation waveforms. Tools, AngSpice, ElkSpice, Batch DC, AC, and transient simulations. Process parameters are manufacturer secrets, must stay local. Agent 3, Humanoid Robot. ROS and ROS2 nodes, servo drivers, camera SLAM, real-time motion controllers. Millisecond level control, cloud delay equals robot failure. Environment sensor data and control algorithms cannot be exported. Agent 4, 3D printer. STL models, G-code slicing, filament parameters, printer serial and LAN API. Tools, Cura, Prusa Slicers CLI, monitor real-time temperature and errors. Large STL files in the hundreds of megabytes upload and download is prohibitively slow. Progressive learning order, easy to hard. Stage 1, the 3D printer agent, the easiest entry point. Simple dependencies, no complex build environments. Tools are pure CLI commands, ideal for your first complete self-built runtime. Stage 2, Digital IC Design RTL agent, medium difficulty. Text-heavy with Verilog code, tools are open-source CLI simulators. Focus on code reading, batch local command execution, structured log parsing. Stage 3, Humanoid Robot ROS agent, hard real-time. Adds real-time hardware I/O, ROS node communication. Requires async tool calling and real-time data stream processing in your engine. Stage 4, Analog Circuit SPICE agent, heavy numerical. Long simulation times, massive waveform data processing. Needs task queuing and batch background simulation scheduling modules. Part 5, Open Source Learning Roadmap. Stage 1, Mini Agent, the ultimate teaching template. Mini Agent is the strongest recommendation. Only approximately 400 lines of Python core code, 0 langchain, 0 heavy dependencies. Native Llama and VLLM local OpenAI interface support, fully offline capable. Built-in tools, file I/O, shell execution, code running. Barebones React loop, tool parsing, context stitching, error retry, no black boxes. Learning workflow, clone, read every line, annotate, delete original, rewrite from memory. Then swap model to DeepSeek or Qwen local and add one custom tool. Nanobot at 4,000 lines, teaching plus engineering transition. Clear layered architecture, LLM abstraction, tool registration, state memory, scheduler. Custom skill plugin support, directly reusable for your EDA or robot tools. Avoid, do not start with LangChain or LangGraph, too many abstractions hide the core. Stages 2 and 3, Advanced Templates and Domain Specialization. Stage 2, Production-grade runtime architecture. OpenAgent, a Go single binary, daemon process, permission sandbox, skill plugin system, local vector memory persistence. OmniAgent in Java, code and EDA-oriented design, project traversal, code parsing. Stage 3, Domain-specific open-source templates. EDA agents, OpenClaw plus EDA extension scripts, AgentForge DAG orchestration. Humanoid robot, airship embedded embodied AI framework. Local LLM high-level planning to ROS and motor control to execution feedback loop. 3D printer, Llama plus custom runtime plus Octoprint API stack. Final goal, complete autonomy. Absorb all architecture strengths, build your own runtime from scratch. Custom name, custom protocol, custom memory format, zero framework dependency. Key takeaways. Number 1, Local AI Agent is not just installing software locally, it's a full closed-loop concept. Local inference plus local runtime plus local interaction, all three mandatory. Number 2, open-weight models depend on vendors only at download time. Runtime is completely vendor-independent, offline, private, fully autonomous. Number 3, agent runtime is not a fixed standard. You can and should build your own. OpenClaw and Hermes are just ready-made wheels, not rules. Number 4, your 4 vertical domains, IC design, analog, robot, and 3D printer, are perfect fits for local AI agent, sensitive data, local hardware, low latency. Number 5, start with mini agent at 400 lines, study production architecture, build your own. The journey from user to creator is the real value of local AI agent. Thank you. Questions and discussion.